Behind me is the mechanical testing laboratory, and in here we measure mechanical properties. Mechanical properties are the properties of a material that involve a reaction to an applied load or an external force. This tube contains any metal rod. The heat emitted from the steam through this tube would heat up the metal rod and it will linearly expand from the heat. And this would be measured by the micrometer dial. In this procedure, you would take water from the sink and put it into the boiler. The boiler would emit steam from the heat, and you would put the steam through this hose and into this tube. At the linear expansion station, we have 5 rods, but 3 of these include, from left to right, aluminum, copper, and steel. The machines to my right are called hardness testing machines. And these hardness testing machines measure hardness, which is the ability of an object to resist scratching or surface indentation. This is a Rockwell hardness tester, and this is the Brinell hardness tester. This is the Hooke's Law station. First, you need to know the precise measuring tools that are needed. This is a micrometer, and this is a vernier caliper. Materials have different elongation properties. For example, metals follow Hooke's Law, and polymers like rubber do not follow Hooke's Law. When weight is added onto the platform, the load that is applied on the rubber band is called the stress. And the deformation that happens to the rubber band is known as strain. Deformations in a material such as holes, cracks, and other things, when you apply the weight on the material, the stress will increase where the deformations are at. One property that can be tested by Hooke's Law is the property of stiffness, which is how much a material resists being stretched or bent, also known as elastic deformation, when a force is applied.
This is our impact test lab station. We use feet-pounds on the Izod and Sharpie scale to measure the amount of force an object like this can take.
This measures toughness. Toughness is an object's ability to withstand energy and plastically deform without rupturing.
We use the temperature changer to adjust the temperature of the specimen, which gives it different properties based on whether it is cold or hot. We have 2 different types of samples. We have steel and we have aluminum. They both, however, have different toughness properties.
In this procedure, the pendulum is lifted all the way to the latching device until it clicks. Then after that, you would put the specimen horizontally for Sharpie testing and vertically for Izod testing. And then you would move the indicating scale pointer all the way to the left. You would use the lever and you would press it. And then the pendulum would go down and hit the specimen, either bending or breaking it. Here are some of the samples that were hit by the pendulum. This set on the left is different than the set on the right because they have different toughness properties. The samples from this set had brittle fractures, while the samples in this set had ductile fractures.
This is our tensile test lab station. We use these steel samples to test for stress and strain. This is the dial that we use to measure the amount of force that we use on the specimen. It has 6 modes, and it measures a certain amount of pounds per division on each setting. These are the controls that we use for the tensile test machine, like this one goes up, down, stop, and we always use the normal load speed, as well as the speed control dial to make sure that we're not going too fast. First, you put the sample up here, close it in, put a collar over it, and then screw it in with a long screw and point it towards the wall so that it doesn't fly out.
This is the compression testing machine, and basically what it does is pushes down this onto this, and it crushes a sample, which is something like this. It can be ice, it can be any material, and you can see on the dial the force that's exerted. It starts at 0, and you can see the pounds. It's 600, 1200, 1800, 2400, etc. And then here, this is the speed, and then this is like the speed range, which is it changes the pounds in this thing.
Behind me are bend testing machines. They measure ductility, which is the ability of an object to resist. plastic deformation.
This is the bend test machine, and what it does is we get samples of materials. This is wood right here, and spinning this wheel pulls on this chain, which, as you can see on the computer, allows us to see how much force is applied, and we use this to find the point at which it breaks. This is the weld test. This machine works to evaluate the strength of a material used in welding, like this. This is steel, for example. Aluminum is also used. And what it does is it pulls it apart to find the tensile strength, the breaking point, and we use that and compare it to welded samples of the same material.
This is our heat treatment station. First, we would put in 4 pieces of metal, close this, and turn it on to 1650 degrees. After the pieces are fully heated to 1650 degrees, we would take them out with pliers, take one out and put it in oil, and then put it on the brick. And we'll take another one out, put it on water, and put it on the brick. The last 2, we would take out one, put it on the brick without putting it in the oil or the water, just so that way it can cool out in the air. The last one we would leave in the furnace to cool down.